Hey everybody. So we are getting into 9.2 multiplying polynomials. If you guys remember from 9.1, we learned how to add and subtract polynomials, which was basically just us combining like terms. Today, we're going to move on to multiplying polynomials, which is, a slightly different process, but also sometimes still involves combining like terms after we've done our multiplication. So, these lessons will kind of build on one another. Okay, so go ahead and get this title, get this first example, and we'll get into it. Okay, so the good news about multiplying polynomials is that there's no need for there to be any like terms. Okay, you can multiply any variables and numbers together. It does not matter. All right, so on number one here, we're going to multiply together these two monomials. Just by the way, monomial because they both have a single term, just to throw in a little definition there. Okay, but we don't need to worry about it. Even though this is just a 3x and this is a negative 2x cubed, okay, we can still multiply them together. So 3 times negative 2 is a negative 6. Okay, remember when we multiply variables, we add their exponents. So an x times an x cubed gives me an x to the power of 4. Okay, and there it is. Okay, so this is using, the same skills we learned, I don't even know how long back, when we were multiplying variables. So just kind of recall those. Okay, but let's keep moving. All right, so real quick, I'm gonna have you guys try a couple of these on your own. Go ahead and multiply these two monomials together. Okay, so on letter A, 5 times 3 gives me a 15. X cubed times x to the power of 1 gives me x to the power of 4. And there we have it. Okay, letter B, same idea. Negative 6 times 8 is negative 48. And y squared times y to the power of 5. Remember, add those together and get y to the power of 7. And there we have it. All right, so yeah, we're going to move through this pretty quick. These are just going to build more and more and more on top of one another and get, I guess, bigger and bigger polynomials multiplying. Okay, so let's see what it looks like when we multiply a monomial times a binomial. Go ahead and get this. All right, so you guys, you're used to seeing this. Anytime we have something outside the parentheses, you guys know where you need to distribute that into the parentheses. Every term inside gets multiplied by a negative 5m squared. Okay, so just take it one step at a time. Let's first multiply these two terms. So negative 5 times negative 4 is a positive 20. M squared times m squared gives me m to the power of 4. Okay, moving on to the next one. Negative 5 times 5 is negative 25. M squared times m to the power of 3. All right, here's something we need to start, I guess, being careful of. After we multiply our, our polynomials, we're going to end up with multiple terms sometimes, and we need to make sure that those we need to make sure that we can't go another step. Okay, if these were like terms, if these both happen to be m to the power of 3s, say this was a 3 here, we would actually be able to combine like terms and go another step. Okay, but they are not like terms because they don't have the same exponents. So that's how we know we're done and it's simplified as possible. Okay, moving on. Let's multiply a monomial by a polynomial that has 4 terms. Go ahead and get this. Okay, so same idea, just more work. It looks like we have 4 terms in here that all need to be multiplied by the 2x to the power of 3. So 2 times this invisible 1 is a 2. X cubed times x cubed gives me x to the power of 6. Okay, 2 times 3 is 6. X cubed times x is x to the power of 4. 2 times negative 2 is negative 4. X cubed times x to the power of 4. And 2x cubed times 5 gives me, 2 times 5 is 10. That x cubed doesn't have any more x's to multiply with, so it's just going to stay x cubed. Okay, so here we are, and the question is, I take a step back and I notice, oh, we actually have some like terms right here, right? We can combine these x to the power of 4s. So let's go one more step. This 2x to the power of 6 is coming down, but we can do this 6 minus 4 and get a positive 2x to the power of 4. Okay, and then this 10x cubed just comes down. All right, and taking a step back, it looks like, yes, now these are all, not like terms, so we know this is as simplified as possible. Okay, so with that in mind, go ahead and try out one of these problems on your own. All right, so this negative 5b cubed gets multiplied by all four terms in here. So let's go ahead and do it. It looks like we get a negative 20b to the power of 8. Okay, looks like a positive 10b to the power of 6. Wait, what am I doing? Positive 10b to the power of 6. Negative 5 times 1, so negative 5b to the power of 6. And negative 5 times negative 11, positive 55. Don't forget that b cubed, though, still comes along. All right, just like the last problem, we have some like terms. We can do this 10 minus 5. So let's bring down the ones that, aren't changing. Okay, which, by the way, when there's this many terms, sometimes, it's not a bad idea to cross them out when things start to get a little crazy. So I brought that down. I'm going to combine these. 10 minus 5 is a positive 5b to the power of 6. All right, and then, cross those out, and then this 5 or 55b cubed, and no more like terms, we're done. Okay, so yeah, we're gonna just keep moving along here. Okay, moving on to multiplying two binomials together. Go ahead and get this. Okay, so you might have done this in the past, or I'm certain you've probably done this in the past. You probably learned to use what they call FOIL, all right, which is like a little cute acronym to remember how to multiply these together. I think FOIL is completely unnecessary because all we're doing is distributing, all right? Just on the last problem, we knew we need to distribute this into the parentheses. It's the same idea with this, okay? We just have two different things we need to distribute into the parentheses. Okay, so start with this first one. This 3a squared needs to be distributed into the other parentheses. Okay, so we're starting with this one. Let's go ahead and do it. So 3a squared times a gives me a 3a cubed, and 3a squared times negative 2 gives me a negative 6a squared. Okay, so I multiplied, I distributed this first term. Now we need to just do the same thing with this second term and also distribute it into the parentheses. Okay, if using these arrows helps, go for it. It's not necessary, but I like to use them. Okay, so 4 times a is a positive 4a, 4 times negative 2, negative a. Okay, so that's that. FOIL, if it helps, feel free to use it, but I think it's completely unnecessary. It's distribution. That's all it is. Taking a look at this, I notice looks like we do not have any like terms, so we know we're done. And by the way, these are all in the correct order. Notice, remember, the exponents are decreasing as we go down. That's what we should expect. So this is looking good. Okay, so I'm gonna have you guys go ahead and try one of these, multiply these two binomials together. All right, so on this problem, starting with this 4b, I'm going to go ahead and distribute it into the parentheses. 4b times b is 4b squared. 4b times negative 2 is a negative 8b. Okay, moving on to the negative 5, I'm also going to distribute that into the parentheses. Negative 5 times b is negative 5b. Negative 5 times negative 5, positive 10. Okay, I'm taking a step back on this one. Careful, if you stopped here, you forgot to notice we do have like terms on this. We can combine this negative 8 and this negative 5. Okay, so I'm going to bring down the 4b squared if you want to cross it out. Combining these gives me a negative 13b. Careful with that. And then this positive 10. All right, now we have no more like terms. Looking good. Okay, so last couple of problems here. Let's look what happens when we multiply a binomial by a trinomial. Go ahead and get this. Okay, when we go to do this, literally no difference. We still have this this 4x here, and it still needs to be distributed into this parentheses. It just so happens there's three things that it's going to be multiplied by. Okay, so just one step at a time. Let's start with the 4x times the 2x squared. 4 times 2 is 8. X times x squared is x cubed. Moving on, 4x times 5x is a positive 20x squared. 4x times negative 1 is a negative 4x. Yep. Moving on to the next thing, I have a negative 3 that also needs to be distributed into the parentheses. So negative 3 times negative 2x squared is a negative 6x squared. Negative 3 times 5x is a negative 15x. Negative 3 times negative 1, positive 3. Okay, so again, taking a step back, are we done or do we have any like terms? It looks like we do actually, in fact, have a couple pairs of like terms. Okay, so let's start with this 8x cubed. There are no other x cubes, so we're just going to bring it down. Since there's so many terms, I highly recommend let's cross it out. Okay, the x squareds, we do have it. We have a 20 minus 6, which is going to give me a positive 14x squared. Cross them out. Okay, the x's, we do have, like terms here. Negative 4 and negative 15 combine to get a negative 19x. Cross it out. And then last thing, now we can see we just have this 3 here, which again, if you guys remember, it's called a constant. But yeah, there's no other constants to combine it with, so it just comes down. Okay, and we can see no more like terms. My exponents are going from biggest to smallest, so we are looking good. Okay, so yeah, last thing, I'm gonna have you guys try one of these. Go ahead and multiply this binomial times this trinomial. Try it out. Okay, so starting with the 2x, gonna distribute it into the parentheses. Okay, 2x times x squared gives me a 2x cubed. 2x times 2x is a positive 4x squared. 2x times negative 1, negative 2x. Okay, moving on and distributing the 2 into the parentheses. 2 times x squared is a positive 2x squared. 2 times 2x, positive 4x. 2 times negative 1, negative 2. Okay, and I'm going through this pretty quick. These are easy to make mistakes with, especially with multiplying the variables together. Take your time, make sure you're not fumbling along. But yeah, I notice like terms, right? We got some x squareds and some x's. 2x cubed, there's no other x cubed, so I'm bringing it down, cross it out. I got a positive 4x squared and a positive 2x squared combined to get a positive 6x squared. Cross them out. Negative 2x plus 4x, or the 4 minus 2 gives me a positive 2x. Cross them out. And then this minus 2, no other constants, bring it down. Okay, no more like terms. Everything's going, exponents going from greatest to least. We're looking good. Okay, so yeah, that's multiplying using, I guess, polynomials. The good news is, nothing too crazy. We've done that math before, and then combining like terms, we've also done that. So there's really nothing new here. It's just doing it all together. Okay, so yeah, I'll see you guys.